In this video, I just wanted to take a second and show you how specifically to use the Explore option in Maple. It turns out it's a really useful tool for being able to kind of visualize what's going on. And it's also a great way of kind of literally exploring when you're not exactly sure what you're looking for. So the way to do this is you have to have some sort of code, something that you would want to do, whether it's solve an equation or plot a curve, and then you insert something that is a parameter. And by parameter, I mean something that is, it looks like a variable, but it's not a variable. It's not a function of something else, and it's not assigned a value. So let me give you an example of what that might look like. So here I've got a DE-plot command, and you'll notice I'm plotting a differential equation. And the differential equation is dy dt equals c times y squared plus b times y plus a. Now, I haven't told Maple what c, b, or a are at all, but I've identified y of t as the dependent variable, and so giving t a range of possible inputs, or I guess you could call it a fixed range or fixed domain, and then the y values, the outputs. So this is going to give me a basically -5 to +5, -5 to +5. So it's going to give me a graph that looks like that. But if I were to hit just enter right now, Maple would give me an error. It basically runs into unknowns, and it's like, I don't know what to do with these things. I've never seen these things before, so I don't know what to do with them. So instead, I'm going to undo that. Instead, what I'm going to do, instead of hitting enter, I'm going to right click on the menu, and one of the options here is explore. And so if you select explore, you'll get a window that pops up. Sometimes it takes a second or two, especially on my slow computer. And it's a little small to see, but you'll notice there's a whole option under these basics of all the things that are in the equation that Maple sees that it thinks I might want to vary. And so we've already defined A, B, and C are the things that I want to use as slider bars. T and Y are the actual variables. Now you'll notice some of the options are sliders, dials, a meter, volume gauge, rotary gauge. You can play around with these and see what they do. I mean, dial's kind of self-explanatory. But I'm going to make slider bars for A, B, and C, and I'm going to let these guys go from 0 to, well, we have to go to 10. How about we just go from 0 to 4, 4.0. Now, I'm going to make A go from 0 to 4.0. I'm going to make B go from 0 to just 4. And C, I'm going to make go from 0 to 4.00 so that you can see the difference between those things. Now, there's some other things in here that you can mess around with. Placement, for where things are, and the animation. Do you want to animate things? I don't really care about all that stuff. But one of the things, and one of the options that you might want to play around with are frames. If you're going to do any kind of animation, how many frames do you want it to animate? Do you want it to loop? Things like that. But since we're keeping things pretty plain Jane, I'm just going to click on the Explore option down at the bottom, and we'll see what pops up. Now what we're seeing right now is a DE plot, just as promised, and this is a DE plot if A, B, and C are all currently set at 0. So it's not that exciting. That means we'd have dy dt equals 0. It is a really boring DE plot because it's a really boring differential equation. It's basically saying the derivative equals 0, and the derivative equals 0 is the derivative of a constant, and that's why you see all of these arrows are horizontal, because the only solution curves for this differential equation would be horizontal lines. Now, as soon as I change A, the A value up here is that an extra constant. As soon as I change A, you can see that the value of those little arrows is changing. The direction is changing, and the bigger A is, the steeper those arrows are, because when A equals, let's put it at 2, or as close as I can get it to 2, if dy dt equals 2, all I'm saying is the slope of the solution curve equals 2, and the only graph that has a slope everywhere that's equal to 2 would be, in this case, the line y equals 2t. And so you see every single one of these solution curves is going to look like y equals 2t. But as soon as I change b and c, that's going to bring a little bit more complexity into my system. So I'm going to drop this back down. It doesn't need to be so big. I'm going to drop it back down to like something boring, like close to 1. But notice, because I made a on the slider bar option have 1 decimal place, I have a little bit more room, as opposed to b, because I didn't give it any decimal places. So I can go from 0 to 1 to 2 to 3 and to 4. That's it. Those are the only options, because Maple takes me seriously. It says, hey, if you want to have no decimal places for your slider bar, we can make that happen. So if you were going from 0 to 20 or something, maybe you don't want decimal places. But from 0 to 4, it helps. So notice what happened to the slope field up there. These are fundamentally, qualitatively different slope fields. This versus this, very different. You can tell there appears to be an equilibrium solution, a horizontal line, right about here at y equals 1, because duh, there's going to be a situation where y equals 1 will give you an equilibrium. And so if I change c, we can make it even more interesting and complicated. And we can change these things as I kind of slide it along here. Looks like it's not all that exciting because some of my other slider bars are kind of hiding the possibility. Ooh. As I make A smaller, there's stuff going on in this middle section. But as I make B bigger, you'll see I can change around what's going on with these things. So it's not terribly dramatic until we get something like that. You're like, wow, yeah, that's totally different. So this is a way that you could, if you wanted to, create an example of, in this case, an autonomous differential equation, and just find out what happens when you change the parameters. So DE plots are great for that kind of thing, but so are regular plots. So for example, if I go down here and I just say I want to plot the graph of, oh, I don't know, ax squared plus bx. Oh, I suppose I should do a times x, or else it's not going to know. Ax squared plus b times x plus c. And I want to graph that between x equals -5 and 5. Now if I hit enter, Maple's going to go, I don't know what a, b, and c are. But if I right click on this and I say explore, now I can select these things as slider bars. And of course Maple says, oh, a, b, and c, those must be the slider bars you want. And so I'm going to make a go from, I don't know, -2.0 to 2.0. And I'll do the same thing for the others just because I'm really boring. And I'm just going to hit explore and see what we get. Too many levels of recursion. That's what it tells me. Now, notice what Maple's saying here is there's probably some trouble with me referring back to A, B, and C, which are defined up here. So I can't use them as for a second time with slider bars. So let's change it. Let's change this to D, E, and F. Now notice that E is italicized. It's not the number E. It's D, E, and F. So now if I say explore, Maple says, okay, make those go from -2.0 to 2.0. So -2.0 to 2.0. And now we say explore. And Maple draws me the graph. Notice I've got 3 new parameters that I can play around with. Now, if I really wanted to use A, B, and C here, I would have to basically release A, B, and C as parameters. And the easiest way to do that would be to just say define A as equaling A, right? And just that kind of resets it. So back to this graph, I've got a plot of a parabola. And if the default is all three of these parameters are equal to -2. But if I change my a value, you're probably not going to be surprised to find out that I can make a happy parabola, right? And that middle term changes the horizontal position of where the vertex is. And then the last one, the plus f, changes the vertical shift. So it takes you back to pre-calc days, right? So it works for a plot. It works for a DE plot, handy. And of course, it works for other things. I'll show you another one that's pretty handy. Just a standard D-solve. So let's say we want to solve a differential equation. So we'll grab a differential equation that might be handy to solve. So I just typed in a differential equation. This is dy dt equals -2y plus e to the t. Okay. Now if I just hit enter, it's going to solve that differential equation without any trouble. But what happens if I don't want it to be -2? I want to know what happens as I change that value. And now I got to be mindful. If I use a, b, c, d, e, or f, then we're going to have problems. So I'll just go ahead and call it g. So g times y of t plus e to the t. Now if I hit enter, Maple's going to go, okay, I'll solve it for you in terms of thinking that that thing is something that I don't want it to calculate with. So if I hit enter, watch what happens. Maple says, okay, here's your answer, but it leaves g as kind of a placeholder. Now I could plug in any number that I want to see what happens. Or I can go back to here and say, I'm going to undo that, and I'm going to say, instead of enter, please explore, Maple. And I want not t, but g to be the slider, and we'll do, I don't know, -5.0 to 5.0. And let's just see what happens to my solution as I change the value of g. Now notice, dsolve equals this. So it's giving me the answer. This is the current answer when g equals -5. So watch what happens as I slide the bar. Oops, I might want to scroll down my window so we can see what's going on. As I slide the bar, you can see it gets all kinds of crazy fractions. But as I get closer and closer to whole numbers or rational numbers, I get more kind of happy answers, I guess you could call them. And so I keep sliding the bar, sliding the bar, sliding the bar. And then every once in a while you bump into something like that where, oh, that's a nice pretty answer. But something, where g is -0.924, okay, you're going to get some crazy fraction answer, right? But I'm able to see what happens to the solution as I make g different. Now you'll notice there's some commonalities. This number down here and that number up there. There's probably a connection as to what's going on, whatever I let g equal. Now as I slide this thing back and forth, you'll notice that as g is positive, we have an answer that is an exponential with a negative coefficient plus an exponential with an unknown coefficient or an integrable coefficient. As I slide the bar further down, when g is negative, this first term is positive. That's an interesting observation. Why is it that way? I don't know. There's something to it, something about the way that constant sitting in front of the y works. So this is one of the things that using explore is really useful for. Now you can use explore in all kinds of commands, and it's really, really helpful. And there's lots more things that you can do with explore, but I want you to literally explore. Try it out. See how you can use it in your everyday mapling. Okay, that's it for now.